Hello everyone and welcome to my channel. My name is RF and in my channel I teach circuit analysis courses, and today we're going to talk about one of the very fundamental rules and terms in circuit analysis known as Kirchhoff's laws. Let's very quickly get started. There are two fundamental terms in circuit analysis known as KVL and KCL, which is the short form of Kirchhoff's voltage law and Kirchhoff's current law. We're going to talk a lot about these in coming courses. Before delving into KVL and KCL, we need to know about the definition of nodes, branches, and loops. What is a node? As the name infers, a node could be thought of as an intersection in a circuit. What is an intersection? It's a point that two or more branches meet each other. It could be a two-way intersection like what we see here, or a three-way intersection. What is a branch? A branch can simply be thought of as a single path between two nodes. So this is a branch, this is a branch, this 1 ohm resistor is in a branch, this 4 ohm is also a single branch. So these intersections are nodes, and the single path between the nodes is called a branch. Okay? And this is a node. What is a loop? The name loop means a closed path, right? So what is a closed path in a circuit? Is this a closed path? Yes. And also this one. And also this one. These are all closed paths. So a loop is actually a closed path in a circuit formed by a sequence of branches. For example, let's consider this loop. Let's call it loop 1. This one is loop 2. And this far right one is loop 3. In loop 1, I have 1 ohm resistor and 2 ohm resistor. So actually, if I want to just draw it again, this is my loop 1, right? And loop 2 starts with 2 ohm resistor and then goes to 5 ohm resistor, and then I have the 10 volt power source. That is my loop 2. So that's the definition of loop, branch, and node. We need to know in order to be more familiar with KVL and KCL, which are Kirchhoff's voltage and Kirchhoff current law. Okay, and now let's jump into Kirchhoff's laws. We start with the first law, which is Kirchhoff's current law. Kirchhoff's current law, also known as Kirchhoff's first law, states that for any node in an electric circuit, the sum of currents flowing into the node, as you can see in this picture, let me just scroll down. In any node in a circuit, like here, the currents that flowing into the node equals the currents that flowing out of that node. So, in other words, the algebraic sum of currents in a network of conductors meeting at a point is 0. So you might want to just mathematically show it as the summation of currents in a node is 0. So if I were to write the equation of KCL in this node, let's call it node A. So in node A, I have I2 flowing into the node and I3 also flowing into the node. So I2 plus I3 equals I1 flowing out of the node and I4 also flowing out of the node. So would be I1 plus I4. This equation is called KCL at node A. And this is the first law of Kirchhoff, also known as Kirchhoff's first law or Kirchhoff's current law. What is Kirchhoff's second law or Kirchhoff's voltage law? Kirchhoff's voltage law denotes that the directed sum of the potential differences, we know that the potential difference is known as voltage. So the sum of voltages around any closed loop is zero. In this picture, we can see there is only one loop, which is this loop here. And Kirchhoff's voltage law states that the sum of currents around this closed loop is zero. So algebraically, I can show it as the summation of voltages in a loop is zero. So if I were to write the KVL at loop 1, let's call this one loop 1, it would be, I have like node D, I start from node D going upward, I see negative V4 plus, let's call the voltage across R1 as V1, as it is in the picture. So negative V4 plus V1, and the voltage across R2, which is called V2, plus the voltage across R3, which is V3. And again, we'll reach out to the same point, which is node D. Then I call it 0. That's the KVL equation. It's the same in all circuits, but there are some challenges and complications that we're going to walk through them together. Thank you for watching this session. So in the upcoming session, I will going to solve several problems in KVL and KCL to make sure that we understood it perfectly. Thank you everyone. Have a perfect day. Let's grow together.